To start off, we'll talk about vectors. So, what is a vector and what is a scalar? So, these both represent a quantity. However, vector will include not just magnitude, oops, but also direction. And scalar, on the other hand, only need magnitude. And so, a familiar example for this is that velocity, well, velocity is a vector. It's actually different with speed, which is scalar, and it's often also the magnitude of the velocity. So why do we need to know about vector? Well, in physics, in fact, there are a lot of quantities that depend on both direction and magnitude, and their effects on other objects also depend on these two. Example is that if I have a ball and something applies a force F to it like this, and it's on a road like this, then different from being applied a force F that have this direction, if you make it a slightly lifted up like this, then the result will make the ball move slower than this direction. And so, knowing the definition, how do we calculate these quantities? And so this is when I'll introduce basic calculations of vectors. First of all is addition. And so before knowing how to add vectors together, you must know that because vectors depend on the magnitude and the direction, right? So if I have a vector maybe A like this, and a vector B, they have the same direction because they're parallel, and they also have the same length, then you can say that A is equal B. And so if I have a vector C, then we'll have C equal A plus B. And you'll notice that the direction of these two from the beginning of C, it moves all the way along here. And from the beginning of B, it moves to the point, and it's also the endpoint of C. And so the whole thing about vector addition is that you only need to notice the starting point and the ending point. Another way for you to do addition is that if I still keep A here, and maybe I have another vector D that parallel to this line and also have the same length, and you can still have A plus D equal C because B and D in this situation are the same. So yeah. And with subtraction, in a previous video, I have already said that if you have an axis X, right? So this would be the positive direction, and so if you move backwards, then you have negative velocity, right? And so the same kind of applies to this calculation. So again, I have the vector C. I have the vector A here, but now the vector B is reversed like this. And so you still go from this, but you meet the endpoint of B here. So that will make it A minus B equals C. But if you reverse the B in this direction, that will make it negative B, right? And so you'll notice that it's still the same addition, but now it's just plus minus B. However, the actual way that we apply this to physics is mostly using what we call components of a vector. And so if I have a vector C, and just like I said before, it can be like this, right? So you call A and B are components of C, or basically I plus B equals C. But how do we actually use this to make problems easier? That's when we introduce component vectors that are perpendicular, which make this a rectangle. So see now it's like this. Yeah, so we'll have maybe this is delta. And for the magnitude, we obviously will have B equal C cosine theta, and this is A equal C sine theta. And yeah, it seems quite basic, but we actually use this a lot. Like in the previous ball example, if we apply the force F like this, that create an angle theta like this, then the equation for this direction, m equal ma x, must equal F cosine theta, and which is also the x component of F. And the xy here will make the ball, will lift the ball up, and that will be a different equation.